All right, let's go through the rational function worksheet. X-intercepts, -3 gives you 0. Intercepts are points, so we got to do it this way. Their multiplicity, that's a bounce, so that's multiplicity of 2, and the behavior because it bounces. Looks like 2 is. 2, 0 is the point of the x-intercept. It has also multiplicity of 2 because it bounces. Y-intercept. Looks like it's a point of 0, 6. Okay. Vertical asymptotes. This is a little tricky. It looks like it obviously classes 0, so it's somewhere around in here, but this one's going up so straight, and this one's still leaning. That's hard to see, but I'm going to guess it's headed towards 1. Now, it's not absolutely clear. We'd have to follow it further up to really get a better idea. But I'm going to say there's a vertical asymptote at x equal 1. And the multiplicity, both sides are going up, so it has to be at least degree 2. So I'm going to say multiplicity of 2 because they went in the same direction at the asymptote. The curve went up on both of them. There looks like there's another one. This one's kind of far, but it's angling over, so it's probably going to be at 3. This one's going up pretty straight, so it's not going to go over much more. So I'm going to say at x equal 3, and this one goes up and one goes down, so it's got to be an odd multiplicity. I'm going to stick with the basics 1 because they go in opposite directions. Domain. That's for what x values is there a graph? For all these x values, there's a graph. So it looks like the domain goes from -infinity up till the vertical asymptote at 1. Doesn't exist at 1. Then between 1 and 3, there's a graph. So for x's 1 to 3, not including 1 and 3, that's why the parentheses, there's a graph. And then there's a graph from 3 on down here, so from 3 on to infinity, there's a graph. Range. Now I'm looking from bottom to top. Looks like this graph goes down to -infinity, or comes from -infinity, comes all the way up to negative maybe 8.6. That's approximate. Gets all the way up to negative 8.6. And then it heads back down. So the range is their stuff from -infinity up to the negative 8.6. Then there's nothing up until 0. But from 0, including 0, I can tell it's 0. 0, and there's y values all the way to infinity. Range is what exists, starting from the bottom and working up. Domain, starting the left, working right. Okay. So solve for what x's is the y greater than 0? Well, the y coordinates here are all above 0. It's equal to 0 there. Then the y coordinates go off to infinity again. Then they come from infinity, come down to 0, and then go off to infinity again. And then they start from negative infinity and come up and get to there and then go back down. So when are the y values for what x's are the y values positive, greater than 0? The y values are all positive all the way up till negative 3. So for x from negative infinity to negative 3, it's positive. At negative 3, it's 0, so I can't include it. It's not greater than 0. Union, after negative 3, it goes back to positive y values until we get to 1 where the graph disappears. So we don't know what it is at 1, union, but just after 1 it's positive till 2, it's greater than 0. So from 1 to 2, but at 2 it's 0, so we can't include the 2, union, and from 2 to 3 it's positive. But at 3 it disappears, and then it's negative the rest of the way. The y values the rest of the way for any x's bigger than 3, it's negative. Y values are below the x-axis. Write an equation for the function. Well, it's going to be y, or f of x, equals, there may be a leading coefficient, we don't know, but it does have to have an x-intercept of negative 3 twice, so x plus 3 squared. Has to have an x-intercept of 2, so it's got to be x minus 2, multiplicity 2 because it bounces, squared, over, got to have a vertical asymptote at 1 with a multiplicity of 2, so it's x minus 1 squared. Has a vertical asymptote at 3, multiplicity 1, so x minus 3. And it has a y-intercept of 0, 6. So if I put 0 in for all the x's, I'm supposed to get 6. So I've got a times, if I put 0 in there, I get 9. Put 0 in there, I get 4. Put 0 in there, I get 1. Put 0 in there, I get negative 3. And that's supposed to be 6. Using x is 0, I'm supposed to get 6. So 36 divided by negative 3 is negative 12. A equals 6 divided by negative 12. And I get A is equal to negative 1/2. So I need to put negative 1/2 in here. And I can graph this on my calculator and see if it looks like that. Estimate the local maximums. Oh, there's a minimum there of 0. And it goes on up forever, so no max there. There's another minimum of 0. It goes on up. And then there's a local maximum of about negative 8.6. Local maximum, negative 8.6. Local minimum, 0 and 0. Happens 2 places, but the local minimums are 0. Okay, problem number 2. First thing I should do is graph this. Graph just the numerator. And since I'm using my computer to do this, can't do a switch to screen recording, so I'm going to do it on a calculator. I'm going to graph the numerator. and that is 1x to the third minus x squared minus 4x plus 4. And to factor that, I'm going to go zoom 4, and it looks like it goes through -2 plus 1 plus 2. Leading coefficient's 1. That's the numerator factor. Now let's type in the denominator. I'm going to leave this one in there, just turn it off by pressing enter on the equal. Come down here and I'm going to type in 2x to the fourth minus 14x to the third plus 26x squared plus 6x minus 36. I'm going to graph that. And it says it goes through -1, so it's x plus 1. Goes through +2, so it's x minus 2. And it bounces at 3, so it's x minus 3 squared. And there's a leading coefficient of 2. Now I could type that in and see if it matches this graph to check my factoring. I could type this in and match it to the first graph I did and check my graphing. But that's what I think it factors to. Are there any holes? Well, I've got an x minus 2 and an x minus 2. So I'm guessing there's a hole at 2. Now I don't see it on either of these graphs. I'd have to graph the whole thing. But how do I find the y-coordinate? Well, I look at the function that's almost the same. Just leave those out and I get 1 times x plus 2, x minus 1 over 2 times x plus 1 and x minus 3 squared. And I'm going to put 2 in for all my x's to try to figure out the y-coordinate of the whole. So I have 2 plus 2, 4, 2 minus 1, 2 from the half, 2 plus 1, and 2 minus 3 is minus 1 squared is 1. That's 4 over 6, which is 2/3. Let's check that. So I'm going to go back to my calculator. And you can do this on Desmos too. If you type in f of x equals this and g of x equals this, then you can write f of x divided by g of x in a separate line and you get a graph. Here it's called y1 and y2. So in y3, I'm going to turn off this one. But in y3, I'm going to go vars, y variables, function, and I want to do y1 divided by vars, y variables, function, y2. I called this y1, the numerator, and y2 this. So y1 divided by y2 is my original function. So now I can graph that. And in zoom 4, it's showing the hole at 2. If I do zoom 6, I won't see the hole. That's because it doesn't try 2 exactly. If I trace it, you can see the x's it's putting into the equation, and you notice it never puts in 2. So at 2, it's about 0.6, 0.9. Let's see, I figured 2/3. That's about somewhere in there. If I go zoom 4 again, I see the hole. And I can use the trace and get close to 2. And somewhere between 0.5 and 0.9-ish, which is about 0.666. I could zoom in at this place, zoom in this area, press enter again. And here's 2, and you can see it's disappearing. Now if I trace as I get closer to it, 0.71, 0.61, or 0.62, so somewhere between 0.62 and 0.71. 2/3 is 0.6666, so it's in the right place. So I'm doing things correctly, just kind of trying to show you how you can check your answers as you're going along. Determine the equations of the vertical asymptotes. That comes from denominators being 0, not including the whole. So we got x equal -1. And the behavior, multiplicity 1, so it goes in opposite direction. Remember, vertical asymptotes, it's either same or opposite. We have one at 3. And since it's multiplicity 2, it goes in the same direction. I can also see that on my calculator if I go back to zoom 4. At -1, one side's going up and one's going down. They're going in the opposite direction. And at +3, they're both going up. They're going in the same direction. And I get that from just typing in the original one. Determine the horizontal or oblique. As x gets bigger and bigger, this is headed towards y equals 0. I can also tell that from this. Degree 3, degree 4. Denominator has a higher degree than the numerator, and whenever that happens, it heads to 0. If they were the same degree, I would use the ratio of the leading coefficients. It would be y equal 1/2 if these were both 3s or both 4s. And if it's bigger in the numerator than the denominator, if this was the numerator and that was in the denominator, I'd have to do long division to find it. Determine the x-intercepts. Oh, we know those. Those are -2, 0, and 1, 0. And at those, they're both 1, so they both go straight, behavior, straight through. Y-intercept. If I put 0 in for the x's, I get 4. Put 0 in for the x's, I get -36. So I got 0 in for the x's, I get 4 over -36, which is -1/9. You do it on the calculator and go second, calculate the value at x equals 0, it'll say -0.111111. 1 repeating is 1/9. 2 repeating is 2/9. 3 repeating is 3/9. -1/9. Graph the function using technology to determine when, for what x values, is the y less than 0. Y coordinates less than 0. This is a little tricky on here. It's easier on Desmos, but you can see it's less than 0 up till there. Then it goes positive. And it's not less than 0 here. On this side, it looks like it's less than 0 for some place over here. So there must be a low spot in here. It must look like on this side, coming down and then coming back up to 0. So there must be a minimum somewhere out here. I'm going to zoom out. I'm going to go zoom 6. That moves me back a little bit. And it's hard to see anything there. I could magnify it. I'll do that for you, but you don't need to. I'm guessing it crosses because, well, I'm not guessing it crosses. It says it crosses at x at -2. So it goes across at -2, but it's supposed to get closer to 0. So it has to have a minimum over here. Let's find the minimum, and then I'll show you it better. So to find the minimum, I'm going to go second, calculate the minimum. That's somewhere between -10 and -1. And my guess is maybe -4. And it says, oh, -4.99. Oh, it's probably at -5 is the minimum. So, when is it less than 0? Well, the whole function is less than 0 until it crosses, which is at -2. So it's from -infinity. The y-coordinates are less than 0, clear up till -2. Then it crosses, it's 0, and then it goes up. It was at 2 because we knew that's the x-intercept. And then it's, after that, it's less than 0 all the way till it crosses on this side, which was at 1. So from -2 to 1, it's below there. After that, it's always positive. So there's when it's less than 0. And when is it increasing? Well, since we know there's a minimum there, it's going decreasing to there, and then it increases all the rest of the way. So it's increasing from -5 to -1, disappears, and then it's increasing again. And it looks like it's increasing all the way through that, except we know there's a hole at 2. So it's increasing from -1 up to the hole at 2. Graph disappears, so I can't use it. Then right after 2, it starts it's increasing right again, all the way till the vertical asymptote at 3. And then after that, it decreases. So there's that worksheet.